All right, welcome to our calculus class. This is going to be a problem out of your homework for 5.4. Okay, so there's the book right there. All right, 5.4. So if you have your book, your 5.4 homework assignment will be on page, this is number 11. So we're on page 231, I believe. Yes, 231. So if you read the whole thing, so I suggest you read the whole question, which is right here. All right, you can take a snapshot there. Read the entire question. Now I summarized it into those few words there. You know, I can't type, I misspell everything sometimes. So there we go. All right, so your job is to design a tank that is 500 cubic feet in volume. The bottom of the tank should be square. So your job is to figure out what size is the square base and how tall is the tank. One condition here, the biggest condition is it's gotta be the lightest. Which now, how would you make a tank as light as possible? So the tank must have the smallest surface area, okay? Now it doesn't really matter what that thin plate of steel is supposed to be like. It doesn't matter. If you want the lightest, the surface area of the tank must be the smallest. All right, so here we go. So this problem involves two equations, or two formulas. So here we go. So this first formula I have here is the volume of the tank, which is the base area. There's your x squared. We don't know what size the base is it gonna be, times the height. That must equals your 500 cubic feet. So now there's two factors in there. There's two variables, your x and the h. Why is it x squared? Because there is a square base. Okay, if you want to think about square base tank, so this side is x. There's the base right here. This side is your x. And to get this area here, there's your x squared. And if you go up that way, there's your height. Forgive my drawing here. So there's the height. So to get the volume is length times width times the height. There's x times h. That must equals to your 500. Okay, think about that for a little bit. You can pause the video and think about it. So now the next equation we have to come up with is the surface area, which is, now why is it all that? Well, you got the area in the bottom. So this is like the steel base that you want. The square area here should be x times x. There is your x squared. Now this area on the side, let me highlight it with different color. So this area on the side is your x times your h. So that's one of them. If you go around that whole thing, there should be four of them. So there's your 4x times h. So you add it together. Think about that for a little bit. Pause if you have to. Okay. So now those two equations has to work together to get your answer. Now what is the answer that you want? You want to find the base dimension, which is how long is the x, and the height, which is the h. Don't worry about this part too much. That's your second part, okay? All right, so let me clear the screen here. So our job is to minimize this. Why are we minimizing it? Because we have to make it as light as possible. It's the smallest area that we're going to use to make sure that it contains that volume over here. Okay, you can ask questions later. The good thing about video is you can't ask me questions right now. So, all right, anyways, let's get to work. So here's my job. So here's our job, okay? So first things first. We have this here, we're gonna, so to minimize something or maximize something, we're doing derivative. That's where we're at. Okay, we're gonna take derivative. But the only problem, well, not the only problem. The main problem right here is you got all these x's with the h in the problem. But there's a way out. Okay, if you take this right here, which is your volume area, convert it into h equals something, you can always bring that back into your surface area volume. Area problem, I'm sorry. So here you go. So your h will be 500 divided by x squared. That's just simple algebra right here. And then if you take this 500 divided by x squared, replace that with the h over here, this will get you the new surface area without the h in it. Notice I use all these parentheses. I will highly recommend that you use your parentheses, or else you're gonna mess up things. In fact, this would be a block by itself. It has nothing to do with the x squared. They're gonna add it together as the total value, surface area. So we're gonna simplify this a little bit. Now your x is canceled with this one x over here. So now you got 2,000, because 4 times the 500, then you got 1x here. Okay, so now the next part is to make this into a derivative problem. Now as you remember, I'm going to have to convert this into a -1 exponent. So it will look like this. It will make it a lot easier to get your derivative. Okay, gotta hold my screen here. So there's a square plus 2,000 x -1. Then now we can take d dx on both sides. So when I do d dx here, derivative with respect to x, so my ds dx will equal 2x plus -1 times your 2,000, then x -2. Okay, we're gonna clean that out. That's you know, algebra. So on the next page, we'll clean it out and we'll set it equal to 0 because we're trying to minimize it. Okay, sorry, I moved the laptop. All right, so let's see, I'm trying to go over my camera here and see if I can do that. Trying to write so you can see it. Okay, this is 8 minutes something already, so I didn't want to go over 10 minutes, but I guess I have to. Okay, so now you have your derivative of the surface area with respect to x equals, what was it? 2x. I'm going to clean this out. So I'm going to rewrite this. That's going to be -2,000 divided by x squared. So minus 2,000 over x squared. Okay? So there's your derivative, your first derivative. Now if you want to minimize or maximize anything, we'll set it equals 0 and then solve for x. So we're going to set this equals 0 and then we'll simplify it. The rest is algebra. Okay? Calculus is algebra at some point. Okay, so let me reduce the size here. All right, so now you got your 2x. I'm going to add this amount to the right hand side. Oh, by the way, at this point your x cannot be 0 right? That should have main error. Okay, multiply the x over here, the x squared times x, so you got, and then divide by 2 on both sides. So you got 2x cubed equals 2,000. Divide by 2, so you got your x cubed equals 1,000. And again, you can pause the video anytime you want. So now to get 1x, the x is the side of the base. You got a cube root of your 1,000. So x is 1,000. Cube root is a 10. So the width of the base is 10. The length of the base is 10 because they mentioned a square. So 10 times 10 is 100. So the volume of this must be 500. Right? So that means the height must be 5. You can do the math there. So we solved the problem. And then the writing on the part B, that's up to you guys. Okay? I just went over 11 minutes right now. All right, thanks for watching. Goodbye.